what I wanted to talk to you about is actually why visual programming matters and why I think this is one of the directions we could pursue. So I'm going to start with a little bit of motivation. Then I'm going to talk about data science, using this as an example. Then I'm going to move to the actual visual textual functional programming paradigm. Then I'm going to, of course, present Luna, because I'm the Luna guy, and describe a bit of its present and a bit of its future. Okay, so let's dive right in. I would like to tell you about the struggles of a data scientist. Well, why data science if this is a functional programming conference? Well, because data science is one of the hottest fields right now. And well, to understand why this is the case, I'm going to actually reuse the slide from last year, showing you the tendency that we are producing huge amounts of data, and it's constantly growing, and we really need to be able to comprehend it, because, well, data is useless on its own. If I give you like 10 gigabytes of logs from the web server, you basically know nothing. You just see a huge blob of text and numbers and maybe some endpoints. But if I start processing it, if I, for example, aggregate it and count how many requests am I getting in every single minute, then I know, I get the graph trend, right? How it is shaped. But then I may run some Fourier analysis and tell you that, well, I see some weekly trends or daily trends, or maybe in the afternoon the traffic spikes. So the data is useful only after I transform it into knowledge. And well, who does that, right? Well, ideally, it's this guy, it's the data scientist who will take the data and then apply some magical methods and give me back knowledge, give me back insights. Well, so let's talk about that. Well, why am I focusing on data science? Well, mainly because it's a hybrid discipline. So this ideal data scientist, he's a guy who has considerable maths and statistics skills, because he needs to be able to apply all these data wrangling methods to extract information. But also, well, he needs to convert this all into a working system. So ideally, he has huge programming knowledge, and if this is to be a production system deployed somewhere and processing data in real time, it's better be distributed programming skills, which are these are hard to acquire on their own. And well, ideally, since as we said, data itself is useless, it's cool if he can transform this data into insights, into domain knowledge. So he needs to actually know what he's applying the data to and the context in which he's working. So, well, that's hard to find. And it's kind of like with CAP theorem. More or less, you can only pick two. If you can pick three, it's usually the guys are super rare or super expensive, more or less both, right? So in most companies, you get two teams. You get the data science team, who come up with all the models and gather the insights, and then the team of devs who actually deploy that into production. And there's a huge barrier of communication, and on this communication level, a lot of things can go wrong. So let's see what really is data science about. Well, first, the data scientist needs to gather the data, be that import a data set or from a DB or crawl a web service, whatever. Then the data needs to be cleaned, because well, you can only process the data that is clean, and this is a really respectable discipline on its own. Then there's this visualize, model, transform circle, because it's performed in a repeated fashion, where you want to, well, model the data somehow, transform it somehow, and then visualize it, because, well, for instance, the data might be, I don't know, might have 1,000 dimensions, right? How do you visualize that? Well, maybe you train some encoder to flatten this to 2 or 3D, and so on and so on. Then once you have it nicely modeled, nicely transformed, you can actually infer something and get some insights, get some predictions. Now, this inference process itself, well, we do learn something, right? But what do we do with the things we learn? One case is that we communicate it to the management, for example, so that they can make more informed business decisions. And then, well, we can also automate it so that it somehow gets incorporated into the whole pipeline of our application. And now, I would really like you to focus on the last two bubbles. So I actually made them bold, because this is the hard part, right? There's a lot of smart people who can do the cleaning, the modeling, the visualization, inference, training of the models, but the communication is, well, it's hard in practice. So, well, obviously you might say there exist wonderful technologies, right? There's Python with the whole NumPy, Pandas stack, there's R, there's Jupyter notebooks and whatnot. Well, it's all fine. You create the code, it even can, run in production, you understand it, but then you need to communicate it to management who is not necessarily technical, and then it all breaks down because you need to write comments, create nice spreadsheet charts. This is a lot to put on a person. Then, well, if that is the case, why not use visual tools? There's great tools, Alteryx, Tableau, RapidMiner. Actually love them. They are very good at what they do. They even have some extensions that allow you to put the models you actually create into production. But, well, in practice, the models that you'll be creating will always run in a setting of a bigger system, perhaps some messaging system with Kafka, Rabbit, or you name it, and then it starts getting problematic. So the visual tools alone that let you compose different blocks are just too limiting. And, well, then if you use them, then you most probably need a team of developers who then take the blocks, the models, and create Python, Scala code, or C++. Now, why do we want to be functional? Well, we are at a functional programming conference, so I guess I don't need to convince anyone. But, well, functional programming actually is a very natural way of processing data. Because when you think of data processing, it's actually, I take the data, I load it, and then I perform subsequent transformations. They're actually very pure when you think about them. And when you actually remember that and do that in a functional way, instead of, just cramming them into a Jupyter notebook and start modifying the data frames in place, then when you do it in a functional way, then you get several nice properties. For example, functional code is very easy to distribute, to run in parallel, right? It composes very nicely, so you can write small blocks and then reuse them across the whole application. And then what is actually one of the nicest things in the functional data processing setting is that when you do a sequence of pure operations, you can actually go backwards and forwards. You can trace back your steps, you can perform them again. You don't change any global steps, so you have full reproducibility. This is, I think, what we often forget when we write, for example, Jupyter notebooks, but this is a really nice aspect of doing it in the immutable functional fashion. Then one argument, because it just so happens that most of the tooling used for data science is languages like Python, R, maybe Julia, which are all dynamically typed. Well, you can augment that with some gradual hints or whatever, but this is not the point. Well, here is a piece of Python code that performs a pretty common operation. It basically tries to choose some hyperparameters for a model, and to do so, it just runs the model over and over, going like through the grid of the parameters for the model and training the model for each set of parameters. And I chose this arbitrarily. This is not a very advanced example, or it doesn't even do anything useful, but the point here is that it runs for quite a long time, and, well, it just so happens that after running for half an hour, it breaks. Anyone noticed? Why does it break? Well, I don't expect you to, and that's kind of my point. Python has this weird syntax that when you leave a comma at the end of the expression, it becomes a one-element tuple, and then the types just don't match. And at the very end, at the stage when you're printing the results, you get a type error. And if you didn't save the intermediate steps, you lose your results, and therefore you lose an hour or two, or depending on how long your model runs for, right? So this is a clear win for static types. Yeah, as mentioned on one of the previous talks, strong versus weak typing is also a strong win for strong typing, but that's, well. Okay, so the question that is natural to ask is, can we actually have it all? So can I have the visual processing part? That's really easy to learn, easy to communicate, right? Easy to create. Can I have the textual programming part when I can easily optimize the code? I can easily scale, I can easily deploy. Can I have functional programming, which is easy to compose, distribute, reason about? Can I have static typing that will help me catch errors very early before I actually start running the code? And can I use it to speed up the development, right? To give me some sort of informed hints about what I can use? Well, just so happens that, yeah, we can. That's kind of the purpose of my talk. And there's this clever tool/programming language called Luna, in which we try to combine all the aspects. So there's the graph, which is visual, and which is more or less the idea you have from the different data flow processing languages, but it's not a predefined set of blocks. You can inspect every block. You can create it on the down to the very statement and variable level. You can customize everything. It's a full-blown programming language. It's just, you know, visual representation, and then it automatically converts to, in real time, to the text representation, which, well, you can think it's kind of like a child of Haskell and Ruby would look like Luna, more or less. So for those of you who haven't seen any of the previous talks about Luna, this is roughly how it works. So when I create a node in the graphical representation, the code is created, right? Neat. And when I create a line of text, well, the nodes are created. Notice how this is actually the very essence of functional programming. So the data flowing from one transformation to the other without any weird, you know, detours or side effects. Well, one of the nice things is that just like with functions that you can also compose the graph, right? I can take a group of nodes and say, let this be a function. I can then inspect it, change it. It's kind of like refactoring for free, but, well, you can view the code depending on what's your level of interest, what's your stake in the code. You can either view it from the very high perspective to basically get a feel for the flow of data, for the overall business logic, or you can actually dive deep down into the details and see, you know, whether you can optimize this or that line of code. Then we mentioned static typing, and that it's not only, you know, this burden that we have to fight with and create those weird type signatures. Actually, static typing helps us be productive, right? If I create a table, so table, think pandas data frame, there's only a small subset of reasonable operations I can perform on it. And the compiler, the type checker, knows them, right? So it can tell you right from the start, hey, this is the set of operations you can perform. Don't even bother looking at any other operations, right? Because they just don't make sense. This is part of why we have type systems. Then one of the things we noticed is that, you know, things generally compose, and we like things that compose. And if you look at the way we create plots, you will notice that the plots compose as well. So this is a good thing. This is not a weird statement, you know, with 1,000 optional parameters and customizing things. It's just, you know, I make two plots, I make a sum of the plots, and now it's the plots combined. It's very, very functional. Right, so does that give us functional data science? Well, I certainly hope so, because like I'm trying to prove, it's such a nice use case. in this example here, we read the data frame, do some analysis, right? Transform it, extract some columns, add some columns, perhaps plot some time series. This is the greenish plots or white, depending on your screen. And we calculate the correlation of the variables. This is what we would normally do in a Jupyter notebook, but here I have both the visual representation, which is really easy to comprehend, and I have the code representation, which is actually ready to deploy. You want to parallelize it, well, go for it. You want to create a web service in front of it, go for it. It just works together. You want to communicate the results to someone. You want to tell them, you know, this is how we process the data. Don't focus on the details. I'm going to show just the pipeline. This is the essence of composability. I can just show them the top layer and everything's clear. Right. So if I'm over the very essence, then basically we can show off. Using FFI into native code, you can plug in a library of your choice. OpenCV is a nice choice for example, detecting people's faces. This can also be done in a functional way, you know. Yeah, but like I said before, this was just to focus our attention, because data science actually gives me a very good excuse to talk about visual programming, functional programming, combination of those. And well, I chose it because it's such a hot topic and everybody knows what the data science does and that they are in demand and so on and so on. But any more use cases? Well, if you're free tomorrow, we are also using Luna to create a framework for serverless computation, in which we represent a function deployed remotely on AWS Lambda as a normal Luna function with returning a future result. So if you're interested in that, and it all composes nicely, and you get a graphical representation of your serverless application, much like AWS step functions, but one that you can actually interact with on the visual layer or on the textual and write it just like code. Yeah, so now I'd like to talk about what Luna has now. So the state of the project right now. Well, this is just a very quick summary, because this is not the first presentation about Luna, and I expect a lot of people to actually know Luna. So we've got the dual visual textual representation that I have mentioned before. We have live visualization, meaning that every node can be visualized, and once it is visualized, once you bring the visualization forward, if you change something along the way in your data processing pipeline, the visualization automatically reflects it, and it allows you to, to track how your data flows. Whereas if you're working in a more traditional notebook-like fashion, you need to rerun the cells, and maybe you manage to change your data in the meantime. So here it's really clear. The nodes are composable, like we've shown before. They are collapsible. Everything is nicely captured by the functional programming. There is a static type system with clever type inference, so you don't actually have to type complicated type signatures. There is a neat data frames library compatible with Apache Arrow, just like Pandas 2.0 will be once it is released. And there's Haskell and Python FFI. Right, but what's exciting is what's next for Luna, and that will, sorry. Oh, cool. And over the course of the next, well, let's say year, you can expect a major type system overhaul to include some more fancy features like dependent types, or maybe a rewrite of the inferencer. There will be a software as a service version of Luna that you can, you run the user interface in your browser, and the computation actually happens on someone else's computers. There will be the visual profiling of nodes. So as the data flows, you actually get hints about how long it took to execute each node, so you can spot the bottlenecks. There will be automatic parallelism, because it's actually so easily done for functional programs, right? This is part of the reasons why we use Haskell and functional languages, because it's distributed so easily. There is JavaScript and R interoperability planned. There is a GUI update coming up, which will be faster, better, nicer. And there is a package manager, like any respectable language. Luna needs to have a package manager so you can install all the nice libraries. Yeah, so this mostly concludes it, but I've got a sneak peek of the new type system for the more functionally inclined of you. And don't worry if you cannot, apprehend it all in one chunk. Well, basically, if you have questions about the type system, you can approach me, or you can actually see the links on the next slide. They contain the chat link, and there are people who will be much more helpful than me in answering your questions about the type system, and perhaps even taking your feedback. So the idea here is that the types will be forming hierarchies. So like if you take a look at the, do I have a pointer? Oh, it's useless. If you have a type, it can have several constructors that are kind of like elements of this type. And then you can write some dependently typed signatures like, this variable needs to be, I don't know, a path, but constructed with this given constructor, or it needs to be this type constructed with any possible constructor but this one. And if you take a closer look, you'll see that the way that the type signatures are written is actually almost the same as the actual function definitions. And that's the key concept, because the programming on the type level actually shouldn't be that much different from programming on the value level, right? So this is more or less what you can expect. But do not be afraid. So if you want to be just a data science user of Luna, then you can safely skip the dependent types chapter in your book, because you won't be exposed to that unless you explicitly want to. And this is kind of the idea behind most of Luna's concepts. Yeah, so I encourage you to stay tuned for the new things to come and stay in touch, both with the Luna team and with me. And yeah, I guess that's all. Thank you very much.
We have plenty of time for questions.
I'm not familiar with Luna, but can you say what is the implementation language?
Implementation of the compiler.
Right.
Well, mostly Haskell.
Okay.
Well, we are getting there.
I have a question. So I guess historically, or for a very, very long time, functional programming, that's true. Visual programming languages haven't sort of become mainstream. Do you have any insight on why that might be?
Yes. Well, visual languages that most people are using as counterexamples to my theory that visual languages are the thing are mostly things from the 80s or from the 90s, where the technology was much, much, much different. Just like in the 70s, people didn't really treat Haskell seriously because, well, the machines were not, or 70s, well, perhaps 80s, I don't know. The machines were much, much slower. They didn't have, all the expressive tools to actually make the visual aspect nice. Because, well, what's visual aspect if it's just, one crudely drawn circle or a weird interconnection of lines? Now we have the GPUs and the graphics libraries to actually make the visual part super interactive, super fast, super intuitive. And then we have some more language research that was done in that period of time, I don't know, 30 years, that actually allows us to, to utilize those new ideas to combine the two. So the outstanding graphics and like cutting edge compiler design and language design.
Okay, thank you. Any more questions?
I can hear you.
Wait as well.
So it's actually not clear to me what the exact state of the project is. Has it been used in production, for example, or?
Well, it's an open source project, so I have no means of actually saying whether someone is using this in production. I believe the state of the project is that it's released. You can go to the GitHub page. If you see the link I'm linking here, just choose the most visited repository, the Luna Studio repo. There's a releases section. You can download the latest release, and it's pretty much ready to use. I mean, it's obviously it still lacks some stuff, like, you know, no software project is ever ready, but it's released and it's ready to use. But it will get better, obviously. There's a from the back of the. So let me just say that at the back we actually have the founder and CEO of Luna, who just came in. So.
Okay, so I just wanted to ask you if there are any use cases other than like data science related that you see using Luna for, because at some point I've seen because I mean data science and you show serverless computation.
This is the use case that I'm working on as part of my PhD thesis. Well, I see Luna fitting in perfectly. There's some papers that I wrote with my colleagues here about, you know, why this is actually a good use case. That actually everywhere there is some data to process or some multiple entities to visualize, the visual aspect helps, right? Not to say that you cannot use Luna without all the visual machinery. You can, it's a general purpose language. So in that respect, it's not, you know, it's not more limited than, say, I don't know, Ruby. It just doesn't have Rails yet, right? But I could imagine someone writing it. You can interact with HTTP endpoints and whatever, with databases.
Okay. Just the question comes from, I've seen a talk, I don't know, it was on some conference, a guy talking about like visual programming and in general, how it can somehow enhance your work and keep you more, I don't know, performative. And there was an example, actually, he was testing like an engine to the game. So there was like a physics involved, and he could actually move around tickers and see the visualization of some kind of functions and so on. Is it possible with this Luna? Because it seems like you can put generic kind of thing in the node.
My answer will be pretty vague, as I know next to nothing about game development. But I've seen some people discussing it on the Luna chat. So apparently they have some nice ideas, and there is stuff like, I don't know, I think blueprints in Unreal Engine that uses more or less the visual idea. So I can't see why not.
So if I may, I would love to answer these two previous questions a little bit more in detail, because I'm working in Luna from more business perspective. And I know that Piotr don't want to come into some confidential materials here, but I could answer that more in detail. So basically, we are right now collaborating with few companies in different domains who are, and we are creating pilots with them regarding using Luna on production. So right now we are collaborating with three main spaces. The first space is banking industry. So we are allowing banks to create credit risk scoring algorithms much faster than previously, and audit the models with auditing department, going step by step on the graph. Which just bridges the communication gap between different domains. The second use case is in pharma industry, where people are, where data analysts who has great mathematical background and great knowledge about biology are discovering new drugs and are discovering how drugs are affecting treatment results. They don't know how to code, but they are right now using advanced Excel or creating SQL commands and creating graphs to visualize and process data and create some data automation is very important for them. So this is the second use case. And the third industry that asks us for collaboration is right now predictive maintenance. So if you've got, for example, a fog system around your devices and you want to create interactive dashboards and change the dashboards and interactively say what is the data flow of data processing there, then you can do that very interactively in Luna, and even business people or people who are working close to this fog infrastructure can define that. Regarding the last question about game industry, actually before starting Luna, I was working close to game industry. So I was working as a technical director in movie studios in Europe. So I was basically creating tools for visual effects creation. Also my other company is right now creating tools for game processing. So I'm close to this actually topic. So creating, we are very closely, we are trying to push Luna into a direction where you have a very interactive workflow. So for example, when you press a node, then and press enter, the node expands to have interactive controls. So for example, if a node accepts an input parameter like number, and you don't connect this number, then after expanding nodes, you have a slider. If it accepts a Boolean parameter, then after an expanding node, you have a checkbox. So after expanding nodes, you have interactive parameters, which allows you to change how the graph operates. So it allows you to very much play with the data and process any kind of data. Our natural fit is with graphics design. So we have a lot of people in our community who are asking about Connection Luna to their game engines and processing graphics, because creating shaders, or for example, processing geometry or creating particle simulations is just a natural fit for such a language. So definitely we are looking into this direction, but from business perspective, we are focusing more right now on pharma, banking, and predictive maintenance. If I could, and I would love to chat with you about other use cases after this talk. Sorry, Piotr, for taking time.
Do we have any more questions for the speaker?
You answered mostly what I wanted to ask, but to be specific, is it easy, just easy, not possible, easy to integrate Luna with Haskell natively in some way?
Sure.
Because I see it's a lot of Haskell behind, so...
Yeah, it's, well, lots of libraries actually are using Haskell behind the scenes because, well...
And the second, in one moment at one slide, I noticed R for statistics computing.
Yes.
Yeah. So is it also easy to mix Luna with R?
Yeah, this is the coming up section.
Okay, I will ask you about this offline, okay?
I wanted to ask about the performance of Luna. Have you checked it on some bigger project? Does it suffer from any scalability issues?
No, I don't think so. I mean, the performance of Luna was drastically improved by the efforts of the year 2018. So I think it's the performance of the backend and performance of the data frames library, which is how you would interact with large data with Luna as a primary way. It's not a problem at all. I mean, the data frames themselves are implemented in a very thought-through fashion and by people who know what they are doing. And well, Luna itself, as I said, if you know Luna from like a year ago, then Luna from now is like an order of magnitude faster, or two. Well, 100, yeah, 2 orders of magnitude.
Just looking at the coming up slide right now, it says that for the time system, dependent times are coming up and also better inference. So aren't those mutually exclusive, or how will that work? So if I know right, dependent types are hard or sometimes impossible to infer, aren't they?
I think I will defer that question to someone who actually works on a type system. I mean, here I'm mostly the presentation layer. I think, yeah, what you say is true. I mean, you can have like the Turing complete language and dependent types and full inference, but well, if you choose wisely what features you want to retain, then you can actually do, you know, what satisfies the user. It very much depends on the setting in which you're planning to use it, because well, when people think like a Turing complete language, they think of it as something really good, right? But if you're, for example, wanting to write smart contracts, then you don't necessarily want to be able to do really everything in the language. You much rather would like to, you know, have a smaller set of operations that you can actually reason about and prove the correctness, prove termination and whatever. So, you know, maybe if the trade-offs are set right, then maybe some use cases will actually benefit from not being able to do one thing, being able to do another thing, maybe even, you know, configure it to some extent by providing some type signatures and so on.
Okay, let's see questions here. Please join us at past for our lightning talks and drinks after that. And let's give our speaker a closing round of applause.